Have you ever wondered how hail forms? Well, today we're going to be talking about the science behind hail. So before we can talk about this, we need to learn the structure of a thunderstorm. So this is a supercell thunderstorm, and these thunderstorms produce the most destructive hail in almost all tornadoes that occur. So let's talk about how they form. So this warm updraft actually causes these thunderstorms to build higher and higher in our atmosphere. They can get so high that they reach the tropopause, which is the top of the troposphere. And if the updraft is strong enough, right where that updraft is, it can actually shoot it above this anvil top and into the stratosphere. So we call this an overshooting top. So this updraft is what's important to hail formation, because whenever raindrops are falling through the thunderstorm, they can actually get caught in this updraft right here. When they get caught in this updraft, it actually causes them to get sent to the top of the thunderstorm where they freeze, because temperatures up here can be well below 32 and actually well below zero as well. So they freeze, collecting raindrops on the outside of them as well, which also freeze. So whenever it gets caught in this updraft, it actually bounces up and down, up and down, up and down. You'll see that in just a second. But whenever it bounces up and down, it'll collect more and more raindrops on the outside, and they will keep refreezing and refreezing. And once it gets heavy enough, it will actually fall all the way down to the bottom to the ground. So your larger hailstones are going to be closer to the updraft, and your smaller hailstones are going to be further away from your updraft. But still, hail is hail, and it can be destructive no matter how big it is. So we can do a little quick experiment with this. So what you need is a hair dryer, and you're going to need a ping pong ball and a golf ball. So what you're going to do, you're going to turn this on a high and cool setting. So you're going to turn this hair dryer on. We're going to take the ping pong ball and we're going to drop it over the hair dryer and watch what happens. So you see it's bouncing up and down like this, sort of. So this is what happens whenever this raindrop gets caught in the updraft. And you can actually tilt it side to side slightly, just ever so slightly, because an updraft is never 100% vertical. It can actually have a small tilt to it. But whenever that happens, it will actually collect those raindrops like I was talking about. And whenever it collects those raindrops, it'll actually get heavier. So whenever it gets heavier, the updraft can't support it. So this golf ball is obviously heavier than that ping pong ball. Let's see what happens whenever we try to drop them on this updraft. It's going to fall right through the updraft, and it will make its way to the surface. So try that out on your own and tag me on Facebook so I can check out you doing it as well if you want to try it out. So now let's talk about how big these hailstones can actually get. So you know you have your smaller ones, which are about pea size. You can have penny size, nickel size, quarter size, $half size, golf ball, pool ball, baseball, softball, CD. So those are just some sizes that you can compare it to. The largest hailstone to ever fall was actually in Vivian, South Dakota in July of 2010. This one was about 8 inches in diameter. It's actually a little bit larger than 8 inches. So this just goes to show you how big these hailstones can actually get. So like I was talking about, it collects raindrops on the outside. What happens if you cut it open? So if you cut it open, look right here. Your original hailstone is in the middle right here, and as it collected those raindrops on the outside of it, it refroze on the outside of it, which you can see by that ring. Once again, it still wasn't heavy enough to fall through the thunderstorm, so it collected more raindrops on the outside, causing it to get heavier. Same thing with this one. There's your original hailstone right in the middle, collected those raindrops and refroze right here, and it causes these rings. So the more rings you have, the more it got sent up into the clouds and collected more raindrops. And whenever you talk about raindrops, let's look at this hailstone right here. These are actually raindrops. All these spikes on the hailstone, those are raindrops. So try out that little experiment, tag me on Facebook, and I hope you enjoyed this mini lesson.